Right? This is what we said last week, right? If we have a medium, if we have mediums of different density, for example, air and water, as the ray enters here, what is called the imaginary line perpendicular here again? Normal. Right? This angle here is the angle of incidence. Right? As it goes from more dense to less dense, there is a change in what? Change in speed, right? So it slows down and it comes towards the normal. So I is bigger than R in this case. Are you okay with that? And then there was a guy named Snell. And Snell observed how sine of I and sine of R were changing. And he recognized that the ratio was equal to something called the refractive index. Right? Something very important here as well, right? What is doing the refracting here? Air or water? In this case, water, right? So this that we worked out here is the refractive index of water with respect to air. If I change to glass then to water, this will change. All the way going towards water. So if I change this material here to glass or copper or anything, right? What will happen is that all the way going towards water, this value will still change. So it's important that we don't call this the refractive index of water. We call this the refractive index of water with respect to air. Everybody okay with that? So you have to be able to label it, right? We also said that because of the change in density, the speed will change. So if I divide the speeds, speed in medium 1 over, let me change this here, speed in air divided by speed in water, I will end up with a refractive index. That's okay? One more thing. If I find the wavelength, well, what's the wavelength again, Gabby? What's the wavelength again? Okay, I'll take that length of one cycle, right? Length of one cycle. So if I take the wavelength in air and I divide it by the wavelength in water, I will also find the refractive index. Right, Satya? Yeah? Yeah. Are you okay with that? So those are the first set of formulas of refractive index. Copy it down. Pardon me, sir. Where you come in about? Huh? Why are you giving you you come to the most thing now? Copy it down. Mr. Follow more to look at. Why don't we say number? You're starting to play game all night right now because. What's the SI unit for refraction, Michael? What's the SI unit for refraction? Very good. Have none. Right? It have none because it's a ratio, right? It's a ratio. Copy it down. Right? Anybody remember how you find speed of a wave? Speed of a wave is what? Frequency by lambda, right? Yeah, put some on here. Somebody say okay. Right? So speed of a wave is frequency by lambda. You'll recognize I have speed here and lambda. How come I do a formula with frequency? How come I can't use frequency of air over frequency of water? That doesn't change, right? So underneath this, right, know that I don't line, but right, know that. No. Yeah, know that the frequency of the wave, note that the frequency of the wave remains constant during refraction. Note that the frequency of the wave remains constant during refraction. Frequency of the wave remains constant. Next, note that. Next dash, note that. Note that. Note that refraction has no refractive index. Note that refraction has no SI unit. What did I just say? Sorry. Refraction has no SI units. Since it's a ratio, right? Since it is a ratio. Right? Just one quick experiment on how to find refractive index. You all may have done this already. Anybody ever did the experiment to find refractive index? What you use? A glass block, right? I wouldn't give you all these steps, but I'll give you the diagram and how to achieve one of them, right? So first thing, you take a glass block and you place the glass block on your outline. Next thing is to draw a little normal here. That's okay? After you draw your normal, Aaron, what you're going to do now is measure off an angle of incidence. So you measure off an angle of incidence. Let's call that I. So you measure off, why everything looking bent? Right? You measure off an angle of incidence. Then you take two pins. Right? Two pins, and you place one pin here, next pin here. And what you do is you go down at eye level. So let's say this is the glass block, and you go down at eye level, and you try to look through the glass block. And by looking through the glass block here, you will see two pins. You have to angle yourself until those two pins become one. Right? And then when you do that, you place a pin to block them. So what you will now have turning is three pins line up like this. Right? All three pins will be lined up. And you do it again with pin 4. Connect them up. This way, we call this way our emergent ray. Right? Draw normal here and then connect it up. From here to here is our angular refraction. Okay? And you do this 5 times. So you have I, you have R, and you do this 5 times. What you will recognize if you do this properly is that this angle I and this angle E, both of them equal. Right? And of course, you'll recognize I bigger than R. When you do it 1, 2, 3, 4, 5 times, you find sine I, you find sine R, and then plot a graph of sine I versus sine R. Plot it up, plot them up. After you plot them up, How do you find refractive index here? Vandina, how will you find refractive index if you plot a graph of sine I versus sine R? Right? Which is the gradient, right? Which is the gradient? Gradient is sine I over sine R, which is the refractive index. That's okay. That's basically the experiment. And you're going to do this 5 times. Change the angles, find the emergent, connect it up, and this is your R. You want these 2 angles 5 times, 5 to 6 times. Pardon me. Come here now. And I'll bring somebody all to the next part. Okay, show that and take his notes. Step 1. But you come on Saturday, you have no class tomorrow, right? So tomorrow is online alone. So you need to go outside. Ready? Ready? Step 1. Everybody write pencil. All right. Step one. Step one. Set up the apparatus as shown above. Step one. Set up the apparatus as shown above. Step two. Step two. Place two pins, pin 1 and 2. Place two pins, pin 1 and 2, P1 and P2. Place two pins, pin 1 and P2 on the first angle of incidence. On the first angle of incidence. Step three. Step three. At eye level, move to the opposite side of the normal. At eye level, move to the opposite side of the normal. And place pin 3 and 4 and place pin 3 and 4 so that all four pins appear in a straight line. Next one, step 4. Step 4, remove pin 3 and step 4, remove pin 3 and 4. Remove pin 3 and 4 and connect to form the emergent ray. Remove pin 3 and 4. To connect, sorry, what's that? Take that in. We remove pin 3 and 4 to connect and form the emergent ray. Step 5. Step 5. Connect the incident ray to the emergent ray. Step 5. Connects the incident ray to the emergent ray. Connect the incident ray and the emergent ray and find the angle of refraction. And find the angle of refraction. And find the angle of refraction. Last step, repeat 4 more times. Last step, repeat 4 more times. And plot sine I versus sine R. And plot sine I versus sine R. All right, online. So that's one of the experiments that you could use to find the refractive index. All right, before we start past papers, I just want to do one thing here. Head up critical angle and total internal reflection. Wow. Head up critical angle, and total internal reflection. Right, just have to find this little lead. Yes, it is you. What when we watch today, hey, what is that? Other paper or something? Yeah, really, boy. I will see if anybody have a free thing here. I will check out this Java. What this one inside the car? All right, better pay for that. This. Check it out. I'll say toolkit anyway isn't just like this. There's it? Yeah, guys, Alright, what's this here, William? Watch this here, right? So, hello, watching. Go back up. Watch here, right? So if you look here, watch this ray here. When I want this thing, come on, move it. Wait, go on. And it's two different mediums, air and water. Wait, we're good just now. All right. And the one that's normally used, yeah, pay for it. So go back to that. All right. So here's what we're looking at. What does normally happen, right? When a ray going from air to water is undergo refraction, right? So there's a special case. There is a special case when this happens. All right? Same thing. Same boundary. Let's go with air and water. And there's a special case when this will happen, right? When the ray hits the medium, right? When the ray hits the ray does not come out here. It stays along the boundary, right? What will be the angle of refraction in a case like this? 90 degrees, very good. So when R is equal to 90 degrees, I is a special angle called the critical angle. That's okay? So whenever the ray starts to travel along the boundary, so it's not in the air nor the water, it's on the boundary, that special angle of incidence Rn is called the critical angle, right? And call that critical angle C. How do we find C? C is sine inverse over 1 over refractive index. That's okay? This formula allows us to find the critical angle. And here's what happens. If we exceed the critical angle in the denser medium, what happens? Anybody remember what's happened? Total internal reflection. So if you keep making this angle larger, it will not enter here, it will undergo total internal reflection. So it will be reflected here. Ready, Tan? Then total internal reflection occurs. All right? So basically, this here will happen. Right? If I is bigger than C and you're in the denser medium, if those two things happen, so air, water, then the ray will be reflected here. I is equal to R. All right? But it only happens if it's in a denser medium. That's okay? If I was bigger than C in air, this will not happen. All right? These are the two conditions for total internal reflection to happen. So the ray doesn't leave water. It stays in the water. All right? So just make a note of this now. So this is a combination of critical angle when the angle of refraction is 90 and total internal reflection. All right? Hmm?
This is saying so. If we exceed critical angle in the denser medium, then total internal reflection occurs. See this? Yeah. Let's start with this now. So take a little read. They give you a last block. Oh, one thing I want you all to remember, right? How do we measure the angle of incidence again? Any angle. How do we measure our angles? Between the normal and the ray, right? Sometimes questions, like we'll do that next week. Sometimes they put the angle between the ray and the material. That's not the angle of incidence, right? You have to work it out. That's okay. Always make sure the angle that you're using is between the ray and the normal. All right. So that's 60 degrees. Is that the angle of incidence? It's between the ray and the normal. So therefore the angle of incidence, right? Right. So if you look here, this is your normal. This is your normal. This is your ray. So that is your angle. So that is correct. Right. You can draw it diagram to one, but don't write anything else. Question said there's a glass block, and the question gave you the refractive index of glass. And they want you to calculate the angle of refraction. How are we doing that? How are we doing that? Samir, how are we doing that? We have the angle of incidence and we have the refractive index. How are we getting the angle of refraction? Step by the form that we will while ago. Make sure I calculate 10 degrees at mass people. Make sure I calculate 10 degrees, right?
Make sure that was P on top. Yeah, Samir, which formula are you using? Look back, you have an angle of incidence, you have a refractive index, and you want to find out angle of refraction. Right, sine I on sine I. N is equal to sine I over sine R. Go ahead, work it out. Everybody get through? Everybody follow why I chose that? Because we have refractive index and we have the angle of incidence. We want us to make R the subject of the formula. Go ahead. Solve it. Let's see what you get. Quick question. Let me pick on Akira. Yeah, good. Akira, do you expect the angle of refraction to be bigger than 60? Or smaller than 60? Smaller. Why? Because it is the more dense medium. Right? More dense medium. So R should be smaller. Do you hear when the B again? No, not yet. Okay. Take it down. Plug it in. 1.5 over 1 is equal to sine 60. Or you solve something like that. Two fractions equal sine we what? Cross multiply, right, later? Cross multiply and work it out. $1.5 to give it. Yeah. What's it mean? 1.5 is the refractive index. Online you can mess with what you get. Cross multiply, work it out. When I cross multiply, I got 1.5 sine R is equal to sine 60. I don't want to round off, right? So because I don't want to round off, I'll leave it as sine 60 for now. Alright? Then I'm moving across 1.5. So I'll get sine R is equal to sine 60 over 1.5. What do I do with the sine after pieces? How do I make R something? What it is? Para como se va. Eu sim, as ideias. So I'm moving across sine. I'm moving across sine and I'll get what? Sine inverse, right? So after cross multiply, I move across 1.5 and then I move across sine. Actually, I do have to many hundreds. Send it back to me. R is how much? 30. Right? Three significant figures, right? 35.3, right? Online, anybody got that? 35.3. 3.6 or 2.6? Okay, Ali, I got it. Anybody else? Right, so here's what I want Annalie to do for us. I'm going to take an Annalie iPad and I want her to draw the part of the way. Right? All the way out of the seat. And the hint is something close to what we did. It's something close to what we did in the little experiment. Alright, but I think you go. Oh yeah. Right, so we're gonna take a look at what will happen to the ray. So draw the block in the meantime, please. Draw the block. and trying to figure out what will happen to the ray. So when the ray enters the glass, what will happen to it? It will undergo what? Refraction, right? So it will undergo refraction. No, stop. We're going to do this here. Hold on, so. Right. We have to read these with the refraction. Right. Very, very good. Right. After this, yeah, no, change your so you know what? Can that work? Can that work? Yeah. What will the angular emergence be? What we learned today about the angle of emergence equal to the angle of incidence. Alright, so we know who not George. Right? Alright, nice. Right, so it will look something like this, right? It will undergo refraction here. We worked out this angle and we got 35.3 degrees. When it reaches here, we draw the normal and it will undergo refraction again, and the angle here will be 6. Are you okay with that? Always remember, angle of incidence equal to angle of emergence. That's okay? Yeah? So answer for part 2 is what? 60 degrees. Very good. Oh, by the way, math people, wait, I'm picking somebody. Ethan, what's the angle there? Sorry, Rajiv. What's the angle there? What is the angle here? Maths. More maths than physics there. What's the angle up there? Yeah. Where the arrow is. Maths, not physics, it's maths. How much? See, I see all the angles now. What do you think, Rajiv? Try to remember this the rule. Same angle, right? Zero. So if here is 35.3, here is also 35.3, right? Zero. Here and here equal. Alright? Part 3. If the critical angle of glass, take a little read of part 3. Oh, we have 5 minutes again. Take a read of part 3 and Diana with some help. If the critical angle of glass is 42, if the critical angle of glass is 42 degrees, what would happen to the ray if it's angle of incidence at DC? So let's pretend I write it in blue now. Let's pretend the angle there is 42.5. What do you think will happen in part 3? Total internal reflection. Why did she say that why did she say total internal reflection will happen here? She correct, but why? Think of what has happened. Think of what has happened for total. What needs to happen for total internal reflection to happen? No, total internal is critical. Critical is when the angle is 90. Total internal, what must happen? The angle of incidence must be bigger than the critical angle. Did that happen? 42.5 is bigger than 42. And is the ray denser medium? Aaron, is the really denser medium? Yes, in the glass, right? Are you okay with that? Are you okay with that? Are you sure? How you find the critical angle again? Sasha, how you find the critical angle? Still on the board. Sine inverse 1 over the refractive index. People with a sharp calculator, please remember to put sine inverse brackets, right? When you're working on these little things. So part 3, write this down. The ray will undergo total internal reflection. Part 3, the ray will undergo total internal reflection. Part 3, the ray will undergo total internal reflection. And part 4, because these two reasons here. Part 4, number 1, the ray is in the denser medium. The ray is in the denser medium. And the angle of incidence is more than the critical angle. Right, so this here is the answer for part 4. Part 4, angle of incidence greater than critical angle, in denser medium. All right. Yeah, stop there. All right, nice. That's it earlier. Next week we do more class papers on this, right? This is the most popular topic in wave, right? All right, online. That's it.